5G is the fifth generation of mobile communication transmission and reception technology. A few years ago, the Federal Communication Commission, which is the spectrum management agency for all non-federal radio operations in the United States, auctioned some spectrum for 5G use. The concern that came up at that time was that high-power 5G transmitters might cause interference to airborne radar altimeters in aircraft. Airborne radar altimeters tell the flight crew in the cockpit how high above the ground they are. There were some impacts on commercial flights and commercial flight schedules. In an effort to be abundantly safe, ITS was given a challenge or a mission to look at the question of how much 5G power might be getting into or could get into radar altimeter receivers.
What we're looking at is the emissions from one of the 5G towers we have here on Table Mountain.
The testing had two major components. One component was to get representative 5G transmitters here to Table Mountain from each of the three manufacturers who build these 5G systems that are deployed in the United States.
So we really able to look and see just how far down the signal from the 5G towers was in the radar altimeter band.
The spectrum measurements were done with a radio spectrum measurement system, which is a mobile laboratory that we have mounted in a truck. The second thing that we did was to actually put a computer-controlled measurement system into a couple of different types of helicopters with an ITS engineer riding in the back seat of each of the choppers operating the measurement system.
As we flew around, we can trace out the power that we saw, both using this heat map and just a regular graph down here, as well as the elevation that we were at the time.
What we discovered from the spectrum measurements was that the power of the 5G in the radar altimeter band was 1/100th of 1/100000th of the amount of power that the 5G was radiating on its FCC licensed frequencies. 5G is safely coexisting with radar altimeters. It is safe to fly. We took detailed emission spectra on the 5G transmitters that nobody had ever had before, and we published those data publicly. So not only the carriers, but everybody else in the world now has these detailed emission spectra that show how the power from 5G transmitters rolls off and goes down as you move away from their frequencies and as you move out of the 5G band. It really was very much of a cooperative effort between the federal government and industry on this project. The federal government in recent years has auctioned hundreds of billions of dollars worth of spectrum to the private sector. Those hundreds of billions of dollars worth of auctioned spectrum are not useful if the new systems like 5G that are being put into them cannot coexist successfully with other systems that are already in that spectrum. The work that we're doing at ITS is the work that makes that compatibility happen, the work that makes that coexistence possible.